5.2, functions. And like I said earlier, I know you guys have had these. I'm positive you had these last year. Input, output, domain range, the X and the Y on the coordinates. We're going to be able to do a whole bunch of this good stuff. Right here, start out with some vocab. First of all, a relation, and I want you to write all this down, please. If it's up here, please put it in your notes. A relation, we're talking about a relation. That is a set of ordered pairs in the form, it could be this, input and output, that could be your form. We know it well as X and Y. Or it can be your domain and your range. So your X coordinate, that is your input, also known as your domain. Your output is the same as your Y coordinate, which is known as your range. So these three mean the same, these three mean the same. And in a test or a quiz, if you forget, here's what you need to do to remember. They're in alphabetical order. I in input comes before O on output, alphabetical order. I before the O. X, Y, alphabetical order. Domain and range, the D and the R, alphabetical order, so you know which one comes first, because they'll show up on tests and quizzes. That helps you remember the order of them. Always alphabetically. Okay, and like I was saying, the input is the X. The output is your Y. And that's what's written here. The domain, that is the set of all inputs right here. All your X's, the first one in your ordered pair. Your range is the Y, the set of all outputs. That's your Y coordinate in your ordered pair. All right, example 1. Identify the domain and the range of the function. They tell us that the number of tickets, this is our X, the cost is our Y. So if these were ordered pairs, it would be 1 and 12. This would be 2 and 19, and so on. For every ticket, it's 12 bucks. 2 tickets is 19, and so on. What are the domains of this information in this set of data? List them. 1, 2,
3, 7, 11,
20. Those are all of our domains. What are our ranges then?
12, 19, 26, 54, 82, and 145.
Excellent. And I can tell you that this is a function. This is a function because the domain right here, none of these numbers in the domain repeat. So it is a function. If at any time we have a repeated number in the domain, or the X, the first number here, it is not a function. Because a function is a relation in which each input value has exactly one output. All right, so if you look here, 1, 2, and 3, those are your domains. There are no repeats. None of them repeat. So it is a function. But you look down here, I've got 1 and 1 and 5. Here, this one and this one, the X, I have a domain that's repeating. So this domain has the output of a 1 and a 3. Not possible. That's not going to make a function on your graph, okay? Not a function. So if the domain repeats, not a function. Here's an example. Now here we're talking, so this was our function. Here's the vertical line test. You can always tell, even if you have a group of numbers, if you have a table or a data given to you, put them on a graph, you graph them. At any time, if you have 2 points that end up on the same vertical line, that's not a function. Even if the 2 points end up here on a vertical line, if they end up on the y-axis, that's still a vertical line, not a function. Why? Fails the vertical line test. You can only have 1 point on each line. Here are some examples right here of a linear function. Any diagonal line, whether it's going in a positive direction or a negative direction, and you're going to be learning about that later, or a horizontal line. That is also a function, because there's no way you can have 2 dots on one line on a horizontal. That is a function. So these are examples of lines that are a function. This one, not a function. Any vertical line that you have more than 1 point on it, it's not a function. We'll do some examples and this will make sense. Please write these down because you're going to have to tell the difference. A non-linear function. Because it can still be a function if it doesn't make a straight line. Right here is a non-linear function. When your points do not make a straight line, it can be a non-linear function. Look at here, these points. That is a non-linear function because look at, not any 2 of them are on a vertical line, right? None of the domains repeat. Here, none of the domains repeat and it doesn't fail the vertical line test. That one doesn't make a straight line. Here, no straight line. We got the curve, y equals x squared. That's what it would look like. We're going to practice one, and we'll practice one like this too. This one's what you would graph if you get y equals x squared. Here's your graph if y equals x cubed. We'll do one like this. These are all functions because no 2 points ever are on the same vertical line. So get those all written in your notes. All right, example 2. What we want to do now is represent each relation as a graph right here, and then we're going to represent it as a mapping diagram. Indicate if the relation is a function or not, and then indicate if the relation is linear or non-linear. Well, first of all, what are we going to have to do? Yep, we have to graph it. So get all these coordinate points on the graph. We've got 5 and 2. 5 and 2. 4 and 1. 3 and 0. 2, negative 1. 1, negative 2. You do not need to connect them at this point. So we have that. By looking at the graph, can we answer this question? Does the relation represent a function? Yes or no? Yes, it is a function. Why?
No straight line.
It passes the, yes, it passes the vertical line test. And we're going to add to this in a second. And also, we'll see when we do this mapping diagram now. Now when we do our mapping diagram, it's best to put them in order from least to greatest, okay? So we have, first we'll take our domains, our x's, and then we'll take our ranges, our y's. Let's look at them. The 5, the 4, the 3, the 2, the 1. Well, that's easy. They're in order already. 5, 4, 3, 2, 1. Then we have 2, 1, 0, negative 1, negative 2. That's easy too. 2, 1, 0, negative 1, negative 2. Those happen to be in order already. All right, so once we get all of our x's in order from least to greatest, then our y's in order from least to greatest, then we draw lines to connect them to their ordered pair, their partner. So 5 and 2. 5 goes to 2. 4 and 1. And these just happen to be across from each other. 3 and 0. 2, negative 1. And then 1 and negative 2 go together. Now I can also, if I didn't have the graph to look at, I can look at my mapping diagram and say that yes, this is a function because see how each one just goes to one line? They each have one output. Each domain, each input has exactly one output. And what happens here? We did not have any of the domains what? Also, the domain didn't have any repeats or repeating numbers. So we didn't have 2 5s or we didn't have 2 2s. So I know that that is a function. Now the second part, is this relation linear or nonlinear? Does it make a line or not?
Yeah.
So yes, it is linear, L-I-N-E-A-R, it is linear. Why? That's easy, it's linear, why?
Makes a straight line.
Makes a straight line. All the points make a straight line. Next example, okay? Graph these. And then put all your domains and ranges in order from least to greatest. If you're watching this online, pause it this time and then turn it back on to see if yours matches mine. All right, does yours match mine? We've got our 4 points on our graph. By looking at the graph, is this a function? Yes or no?
No. Yes.
Is this a function?
Yes.
Big old no. Why? What happened here? What happened?
Oh, now I'm seeing
That is not a function because it fails the what?
the line.
What line test?
Vertical line.
Yep, it fails the vertical line test. Oops. Ah, look what I did. I can spell. Spelled line before vertical. So looking at the graph, it fails the vertical line test, so we know that is not a function. If we didn't have the graph, we'll go over here to our mapping diagram. Put them in order, my x's. I have a 1, a 3, a 0, and a 1. So 0, 1, and 3 in order. But notice the 1 repeated, didn't it? I only have 1, 1 here, though. You don't write it twice. And then I have -2, -1, 3, and 4. Now let's draw it to its matching one. 3 to a 1 to a -2. That goes here. 3 to a 3. 0 to a 1. -1. And then 1 to 4. So notice, this has a repeat, doesn't it? The domain repeated. You cannot have 2 outputs per 1 input. You can only have 1 for each. So this repeats. So we can also add and also, and because what? The domain or the x in parentheses, because that's your x coordinate, repeats. Is this, now I gotta take this off though, because that was just showing your vertical line test. I'm trying to get rid of it. Let that go away. Ignore that line, I can't get rid of it, that I used for the vertical line test. Anyway, do those 4 dots. Do those 4 dots make a linear or non-linear graph? Which ones are they? These four dots right here, is it linear or non-linear? It is non-linear. Why?
Does not make a straight line.
Exactly. It doesn't make a straight line. Easy as that. Let's go to this one. All right, graph all of these again, putting your ranges and your domains in order from least to greatest. If you're watching it on video, pause it so you can get yours done to see if it matches mine. All right, so when all graphed, I got my numbers in order from least to greatest. First, I like to look at the graph. Pretty easy to tell if it's a function or not. Is it a function by looking at the graph? Yes or no? Yes. Why? It passes the vertical line test. What else? And
No numbers, no domains repeat.
no domains repeat. But then they go, Mrs. Lennon, but the ranges repeat. You have two, what do we have two of? Didn't something repeat?
Ones, zeros.
So we have a -3 to 3, that went to here. -2 to 2. Then we had -1 to 1. 0 to 0. 1 to 1. 2 to 2. And 3 to 3. See how we had repeats on the 3s, the 2s, and the 1s? 3, 2, 1. Those are those repeated in the what though?
Right.
In the range. Is that okay? That's fine. As you can see when you put them on the graph, if the ranges repeat, if your y repeats, they're not going to be on the same, they'll be on the same vertical or horizontal line. See here? They'll be on the same horizontal line. But that doesn't matter. They can be on the same horizontal. It's just the vertical line test that they can't fail. Is this linear or non-linear? Non-linear, and why?
Doesn't make a straight line.
Doesn't make a straight line. All right, let's go to example 3. Create the described function. Check your answer using the graph as needed. For part A, letter A, they want us to make a non-linear function using a graph. Well, in our vocab and stuff, I gave you all those examples of a non-linear function. Give me an example of one that I could draw on here.
The last one you just did.
The last one that I just did, exactly. What's another one?
A curve.
That one. And then we have the,
Half circle.
like the U, the half circle. And then what was the fourth example that I gave you? The points when they're just kind of all over the place. It's like a scatter plot, right? So you could have had any of those four on there as a non-linear function graph. For B now, what they want us to do is a linear function using a table of values. So let's make a table of values. Go like this, make a T-chart. You got your X and your Y. Let's see, let's pick, you guys just pick, give me any ordered pair here. Close, let's stick close to the origin. Give me an ordered pair.
1 and 2.
A what?
5,
5 and 2? Okay, so let's go like this. 5 and 2. That's our ordered pair. Plot it on your graph. 5 and 2. Now I have to have another one.
4 and 1.
4 and 1. Now we're talking linear. Will that make linear? 4 and 1. So far so good. Everybody agree?
Yeah.
Okay. I need to have some more.
3, 0.
3 and 0. Another one, please. 2, -1, you said?
Yeah.
Good. Excellent. So what did we have to do to our input to get our output? What did we do to our 5 to get to a 2?
subtracted by 1.
We went 5 and we minus 1 to get here?
3.
We minus the 3, didn't we? What'd we do here? Did we do the same thing here? Is that 4 minus 3? Does that give me my 1? Does 3 minus 3 give me 0? So does 2 minus 3, does that give me a negative 1? It does. What if I wanted to use the input of 7? What would it have to be then?
4.
7 minus 3 is 4. Does 7 and 4 work on our graph? 7. 1, 2, 3, 4. Does that work? Aha. So what would our equation be here? This would be y equals, what did we do to our x?
X minus 3.
We did x minus 3. So that is the linear equation you guys just gave me to graph. This is y equals x minus 3. We took our x and minus 3. Let's go over here now for the last one. I believe this is the last one in our notes. They want us to make a non-linear function using an equation. Now you can get that from the examples I gave you on your front. You guys write the examples down that had the equations with them? What was one of the equations? Y equals what? You want to use x squared or x cubed? Want to use x squared? All right, we'll do y equals x squared. So draw your t-chart, x, y. Give me some x's. Give me an x.
6.
6? So if I put a 6 in here, what's 6 squared? 36. Does that one fit on the graph, 6 and 36? Nope, that'll be too high, but it still would be, it would work if our graph was bigger. How about a smaller one? What should we try?
2.
2. So if x is 2, what is 2 squared? 4. So can I plot that one? Does that fit here? 2 and 4. Yep, that one works. So what else do we want to try? 3? 3 and what? What's 3 squared? 9. Does that work? 3 and 9. 1, 2, 3, 6, 7, 8, 9. Good. We need more points. How about 0? That's always an easy one. What's 0 squared? 0. So we need one right at the, what do we call this? The origin. Let's do some negative numbers to get over into the other quadrants. What's a negative 1 squared? Negative 1 times negative 1 is positive 1. So negative 1 and a positive 1. Right there. I need some more because we still don't know where this is going. Do negative, we used a 3, let's use negative 3.
2 and 4.
What's negative 3 cubed? Or squared, sorry. 9. So let's go negative 3 and up to the 9. Do you see a pattern here? What's going on?
We're doing opposites.
What's it making? A non-linear equation. Okay? And it's better. The more points you have, the more accurate your graph is. All right, your homework for Monday will be pages 4, 5, and 6. Pages 4, 5, and 6.